the recording game on. I'm doing recording. Hey Logan, how you doing?
Good, how are you?
Well, thank you. So today we are going to cap off the last of our reintroduction into trigonometry. Okay? Our reintroduction, meaning most of the stuff is review. Most of the stuff has been reviewed. I'm going to close this door real quick because I think this is the noisiest hallway in the school. You think?
Especially this time of day.
What's that?
Especially this time of day.
Yeah, it's worse. Yeah, this is still technically lunchtime, isn't it?
Yeah, you lost your feet. Oh, it's on you.
Phone again. All right. So, but this part's kind of a little different. We really didn't talk much about this last year in Algebra 2. In Algebra 2, we always went one way. We always went with an angle and found a trig function value for that angle, right? So I give you 30 degrees or pi over 6 radians, and then I ask you, what's the sign of that? You say 1/2, right? Inverse functions do what? They take that trig value and give me an angle. Okay, so there's some consequences for that. One consequence is, can I take an inverse trig function of an angle? If I say I want an inverse sine of pi over 6, can I do that? No. We'll go over that a little bit later on. But right now, I just want to go over what we're going to be able to do after this lesson. At the end of this lesson, we're going to be able to evaluate and graph inverse trig functions. That's the first thing. Second thing is we're going to be able to evaluate compositions of trig functions. Remember compositions? Fogg and Goff. Remember Fogg and Goff? G of f of x and f of g of x. We're going to be able to do that. Okay? So, first of all, everybody put away your calculators. Logan, put away your calculator. All right. There's a math teacher humor there. All right. Consider the fact that sine of some angle that I'm calling theta equals 1/2. What angle or angles would produce this result? I want 4 solutions, and I want your solutions in radians. 4 solutions. How many can you think of, Haley? Can you guys produce a unit circle from which to work?
What are the radians again? Like going up around the circle, like going from
0 to 2 pi.
2 pi.
Yeah, 0 to 2 pi. Go ahead, Josh. Well, is that an angle? What is
The
it?
angle will be 45 degrees.
Does that 45 degrees produce a sine of 1/2? Yeah. Well, what sine?
Huh?
Well, what's the function sine do for me?
Ugliness what?
If I'm looking at a triangle, how do I find sine of an angle? SOHCAHTOA. Sine is opposite over hypotenuse. Okay. Yes, we're trying to find the angle in degrees. I don't agree with that right triangle. Well, if your side lengths of a right triangle are 1 and 1, the hypotenuse is not 2. It'd be the square root of 2, right? How you doing, Spencer? I marked you absent.
Yeah.
So hit me at the end of class. I don't think you're on my you're on my list for that. So hit me up at the end of class.
I'm pretty sure I am. You check last.
Okay. All right. Hang on. hit me up at the end of class and I'll fix it, okay? All right, so, has anybody got an answer? 30 degrees. Do we know what that is in radians? Pi over 6, right? Pi over 6 is one answer. And that's also 30 degrees. Good. How about another one? 150 in degrees. What is that in radians?
5 pi over 6.
Okay. 5 pi over 6. That's 150 degrees. Okay. Is there any others? Think coterminal angles. What does coterminal mean? It's back to reviewing our definitions. Same initial side and same terminal side. Hence the coterminal, right? So, Pete lost me. Pete lost me. Pete's got me back. So, what angles have the same initial and terminal side as pi over 6? 390, 360 plus another 30. I'd buy that. How about a negative angle? Is there a negative angle that also is equal to this? Negative 330 or negative in radians? 11 pi? 11.6 pi? So negative 11 pi over 6, which is the same as negative 330. And then lastly, how about a coterminal angle in the negative direction for this guy? For that guy? What would that be? It'd be negative, right? This is 1/6 less than pi, right? So maybe it should be 1/6 more than pi in the negative direction. What's 1/6 more than pi?
7/6 pi.
7/6 pi. There you go. Or 7 pi over 6. And that's going to be negative 210 if I converted that to degrees. Okay. So I got 4 values. I got 2 positive, 2 negative. So let's put those down on the next page. We're going to fill in my angles first, and then we're going to talk about what the sine, or the cosine and the tangent are. So we got pi over 6. We got 5 pi over 6. We got negative 11, 5 pi over 6, negative 11 pi over 6, and negative 7 pi over 6. Okay, now, let's stick with the easy one. What is the cosine of pi over 6? The cosine of pi over 6. Square root of 3 over 2. Good. Which means, how my cosine is going to change? Can I just do that? Because if one triangle is sine of 1/2 and the cosine of 3 pi over 2, aren't they all going to be? It's the same triangle, right? What do you mean, Alex? When you say it's a different quadrant, what do you mean? Some of the cosines are going to be negative. Which ones? Remember, cosine is positive over here, right? So where is 5 pi over 6? In which quadrant? In second quadrant, right? So is that going to be negative? Negative cosine? Okay, so then this is negative negative root 3 over 2. What about negative 11 pi over 6? I start here, and I'm going negative, so I'm going down, and I go here, right? So that's going to be positive cosine, right? So that's going to be root 3 over 2. And then 7 pi over 6, I'm starting right here, going this way. This is pi, and then another 1/6. So I'm in this quadrant again. So positive or negative cosine? Negative cosine. Negative root 3 over 2. Now, what was the one thing that all 4 of these angles had in common? How did I compile this list of 4 angles? The sine of it was all what? Well, positive 1/2, right? These were all positive 1/2. So, to figure out what the tangent's going to be, how do I do that? What divided by what? Sine divided by cosine. So tangent of theta equals sine of theta divided by cosine of theta, which in this case equals, I know my sine's always 1/2, right? So 1/2, I'm going to do my divided by like this. And then what am I dividing by? Plus or minus root 3 over 2? Now, review, back to like 7th grade. How do I divide a fraction by a fraction? Multiply by the reciprocal. So, this equals 1/2 times plus or minus 2 over root 3, right? And then I can either simplify before or after I multiply, right? Let's simplify before. And I get plus or minus 1 over root 3. What's Dawson's lemma? Not radians. Radicals are in the denominator are dumb. So to change this and get rid of the radical in the denominator, I multiply by root 3 over root 3, I get square root of 3 over 3, plus or minus. So every one of these is either going to be a positive or a negative square root of 3 over 3. Which ones are positive? Which ones are positive? Which ones? Sine is always positive, right? For all 4 of these, sine is always positive. So I got a positive divided by a positive gets me a positive. So this is going to be positive root 3 over 3. Positive divided by a negative gets me a negative root 3 over 3. Positive or negative? You got that, Spencer? And then here, Spencer, negative root 3 over 3. Good. Okay. A little bit of review there. A little bit of review. Now, what's that? When we ask ourselves what angle produces a sine of 1/2, like we just did that first page, right? When we ask ourselves that question, what we're really asking is, what is the inverse sine of that trig value? That's what we're asking. So when you see sine to the -1, I read that inverse sine. We also give another name to that. We also can call it arc sine. So, everybody break out their calculators right now. Does anybody have that on their calculator? Show of hands, who's got that on their calculator? Everybody. Nobody's got arc sine? Has anybody got arc sine on their calculator?
It's too much more words.
Yeah, I've seen it on calculators. Maybe it's not as common as it used to be. Nobody in the other class had it either. But you're going to see it in books. So be mindful of that, okay? Now, for this one, I want you in calculators and I want you in degree mode. So make sure your calculators are in degree mode. That way you're not inputting radian values. All right. Let's see your calculator here. This is important. So, right now, you're in degree mode right there. Okay, see that? Now, to change it, you hit this mode button, and see how it's in degree. You just hit that and go to radian, and then you're ready. Well, we're going to go into degree mode right now, okay? Yes. All right, so I want you to find arc sine of 1/2. Everybody do that and tell me, write down what you get. Write down what you get if you do arc sine of 1/2. Did you bring a calculator today, Spencer? Bring calculator every day. Every day. Logan, do you need a calculator? And I want you to get good at a calculator.
I have my own calculator that I know how to do this. I just didn't bring it today. I don't need to do that.
I'm being stubborn. I can be more stubborn than you. You know why? Because I'm paid to be stubborn. So, what do we get when we do inverse sine of 1/2?
30.
You get 30. 30 degrees. Okay, and that makes sense because every time we do sine of 30, I get 30. Every time I do sine of 30, I get 1/2. Yes. Wait a second. Now, do arc cosine of square root of 2 over 2.
No way. Unbelievable.
What'd you get?
45.
I can't, my sarcasm meter's broken.
45.
Is that sarcasm though?
Well,
A little. Okay. All right. All right. So this one was 30 degrees. This one was 45 degrees. Find the arctangent of negative 20,000. Arctangent of negative 20,000. What did you get? Yeah, but don't want to say 90. Why don't I want to say 90?
it's not exactly 90.
It's not exactly 90, but usually I can round, right? Why don't I want to round this time? Why not? What's the tangent of 90 degrees? Remember, this tells me what angle gives me a tangent of negative 20,000, right? Well, what is the tangent of 90 degrees?
It's just error.
It's the domain error, right? Why? Yeah, sine divided by cosine, right? And cosine of 90 is 0. And can we divide by 0? No. So this is negative 89.9, and I'll just put a repeating degrees. It's not repeating, it's you're right. 9. I'm just going to do that in degrees. It's really dang close to 90 degrees. But I don't want to do that because I know there's no such thing as a 90 tangent of 90 degrees. We need to take care when we're doing inverse trig functions, though. Think about this question. Put your calculators away for a second. Just turn them upside down. And consider what the arc sine of 2 would be. In other words, what angle produces the sine of 2? Any intuition on that? Can you think of an angle that produces a sine of 2? Go ahead and break out your calculators now. Pete's having a hard day. Pete is having difficulty. Yeah, why is that? You know why? It's your amazing hair game. It's your hair game. I'm telling you. What happened? Domain error. Why is that? No. Let me sketch out. Let me sketch out sine. Does this, right? Yeah. What's the top? What's this? Yeah, the max is 1, and the minimum is -1. So if I want to find something out here, what angle produces that? Purple, because aliens don't like pancakes. Is that wrong? You knew what I was talking about, though, right? Anyhow. So we need to be mindful, right? If I do an inverse sine or an inverse cosine of something, I better be doing an inverse sine or a cosine of something less than the absolute value of 1. But what about this tangent? Why could I do it at tangent? Dude, I wanted Pete to get that so bad. Oh, thank God. He missed it. Pete was slow.
Come on, Pete.
Pete was slow. Why was I able to do an inverse tangent of -20,000?
Because it's a weird line.
It's the weird line. Here's what I'd like to hear. What is the range of sine and cosine? The range. The definition of range, again, is the list of the y's or the outputs.
Yes.
What's the sine and cosine? Range of sine and cosine. -1 to 1, right? What's the range of tangent? Range of tangent is the reals, right? It's all real numbers. All real numbers. That's why I can do tangent, but I can't do sine and cosine that way. Okay? Another reason to take caution. Let's use our calculators once again. And let's do degree mode again. I'm going to ask you, what angle has a sine of -1/2 and has a cosine of -√3/2? So here's my suggestion. Let's do arc sine of -1/2. And what do I get? You get -30. -30 degrees. Okay? And the arc cosine of -√3/2. And what do I get there? Don't forget the negative. 150. Why am I getting different answers? Why am I getting different answers? Let me ask you this. Is this the right answer? Oops. Is that the right answer?
Oh.
Is that the right answer? Shaking your head. Get a yes over here. Let me ask you this. Everybody, punch in 150 and hit sine. What do you get? Do you get -√3 over, or I'm sorry, do you get -1/2? Sine 150, you get negative 1/2. You get positive 1/2, right? So let me ask you, if I got a negative sine and a negative cosine, what quadrant am I in?
Very wrong, yeah.
3, down here, right? Below the x-axis and to the left of the y-axis. I'm in third quadrant. Are either of these angles in the third quadrant?
No.
No, this one is in the fourth quadrant. Negative 30, it's in quadrant 4, right? This angle, quadrant 2, right? Right there. What's important here is, see if you remember this term from last week before spring break, reference angle. Who remembers reference angle? What's the reference angle in this particular scenario? Supplement. Supplement that makes 180, right? So what's the reference angle that we're looking at here? What angle am I concerned with? I'm concerned with 30 degrees. That gives me the numerical value of sine and cosine, right? And then I have to use my situational awareness to figure out what quadrant I'm in to find the actual angle. We clear on that? So the calculator does not necessarily give us the answer. We still have to do some reasoning after we play with our calculator. Does that make sense, Spencer? Okay. We can also avoid some of this by using our unit circle. Because our unit circle's already got that stuff encoded, doesn't it? It becomes trickier when I ask for other angles. Pete is having a hard day. It gets trickier when I'm asking for angles that are not pi over 6 or pi over 4, right? What if my reference angle is 37.278 degrees, right? Or my reference angle is pi over 71 radians. Then I'm kind of posed, right? Unit circle doesn't help me. Not as much anyhow. Okay. Now, use whatever tools are appropriate, whether it's your noodle, unit circle, or your calculator. So tell me what the arc sine of the sine of pi over 2 is. So write it down on a sheet of paper. Why do you say that, Logan? What's your reasoning? They're inverse functions. So what does an inverse function do? They undo the original function. Now, that's one riddle. Here's extra riddle. Find the arc sine of the sine of 5 pi over 6. Is that the one I want to do? Is that the one I want to do? Yeah. I want everybody do this one. Everyone do this one. What do I get when I do this? Punch in your calculator, see if you get the same thing. I like your reasoning, Logan. Wow. I'm gonna just move very slowly. See that? You can keep up with me when I'm slow. I'm just too fast in my old age. So what do I get when I do the arc sine of the sine of 5 pi over 6? What? Josh? 1.57. Multiply that by 6 for me. Multiply that answer by 6.
You get 2.61.
You got 2.61.
That's what I got.
Yeah.
Pi over 6.
Times 6. You're not supposed to do that. You're supposed to get that? No, you're not supposed to get that.
You're supposed
The
to
inverse sine of 5 pi divided by 6. Oh. That's what you get.
what?
2.61.
Oh, yeah. That's in pi.
Nope. Oh, you know what I'm doing? Oh, I know exactly what we're doing, Logan. Let me ask you this. Ha! I planted this trick and then I fell for the trap. What is that angle measure in? What units are those in? Radians.
Not degree.
Not degrees. And what mode did I tell you to be in earlier?
Degree mode.
Degrees. So we need to change to
Hey.
radian mode. So let's do that. And then do inverse sine of the sine of 5 pi over 6. And then you get 0.52. Now, multiply that number by 6.
3.1415926 pi.
So pi over 6, right? So I get pi over 6 when I do this. So the calculator gives me pi over 6. But my intuition told me, because I know what inverse functions are, it told me 5 pi over 6. What's going on there? Why?
Taking
It is a different quadrant. That's good intuition, Alex. This is the reference angle of that, right? There's some wisdom there. Let's go here. I got sine up here. I'm going to graph inverse sine on the same thing. But because I'm doing it on the same graph, my inverse sine is going to be basically like this. I'm going to do inverse sine along this axis. So basically, I'm thinking about what angle. So I got angles right here, right? 0 radians produces what sine? What's my sine over here? 0, right? If I go pi over 2, I'm at 1, right? So at pi over 2, I'm at 1 radian, I'm at a sine of 1, which is about right there. Okay? And then I go back to pi. What's my sine? 0 again, 0. Here, I go down to 3 pi over 2, and I'm at negative 1, which is about right there. Okay? And then at 2 pi, I'm at what again? 0. Sine is 0 here. Okay. Now, let's do the other way. Going down to negative pi over 2. My sine is negative 1. Boom. 0, right? 1 and 0, right? So 0, 1, and, 1 and 0. So my sine curve, or my inverse sine curve, looks like this.
That's class.
Okay. Now riddle me this.
That is.
Is that a function?
No. Yes.
Why do you say it's a function or that it's not a function? What's the test for functionality? Vertical line test, right? Right. So is that a function? No. We'll finish this up tomorrow, and this will take about 10 minutes for us to finish up tomorrow, and then the rest of the day will be a work day, which is on Friday.